Let's see question 921A. Determine effective focal length of combination of two lenses in 910. They are placed 8 cm apart. Let's see what's 910. Two lenses, convex of focal length 30 cm, concave of 20 cm together. When they are placed together, we calculate the effective focal length this way. Minus 60 means it's a diverging lens system. Here we are said that both the lenses are placed 8 cm apart. Find their effective focal length using this formula. D is the separation. So substitute all the values. We find it as minus 300 centimeter, which means it's a diverging system of lenses. Now we are asked, does answer depend on which side of the combination a parallel beam of light is incident? So this is parallel beam of incident light is the incident ray. Let's say first it falls on the convex lens. We'll find its distance where it is obtained using this equation. We know the values. Object is at infinity, so V is got to be 30 centimeter. Let's say it is B1 because it's the image formed by the first lens. So this is the image. It's a convex lens, converges, here it falls, and we are finding the distance is V1 is 30 centimeter. Now this will be the object for this lens, so it will be at a distance of this 30 minus this 8, so it is at a distance of 22 centimeter. The image distance, object distance, is always calculated from the center. Here it goes right, so it is object distance is 22 centimeter. Now we have U2 as 22, F2 is given. Now we find V using this formula. We get minus 220 centimeter. See, this is the object for this lens. So from here it diverges, it appears to diverge, and it appears to, or it diverges from this point. That point is 220 centimeter from this lens. That is what V2 we have got. Now to find out the from the center of the lens system, we have to find out the distance. It is 4 centimeter. We have to subtract from this distance, we have to find. So it is minus 220 already, minus 4, it is minus 216 centimeter. So this is the image form. Now let us consider the next case when the incident ray is falling initially on the concave lens. So here it falls. We will find its image distance. So this is the image object value from infinity. F1 is known. We are finding V1. It is minus 20 centimeter. When a ray of light falls here, it gets diverged, and it appears to diverge from this point. So this value is got as our image formed by the first, which is minus 20 centimeter. This is minus 20 centimeter. Now for the convex lens, we have to find V2, and we know we are given F2 and U2. We should be knowing U2. This distance is 20, and when you add it with 80, we get 28 centimeter. Object distance is minus 28 centimeter. Substitute, we find V2 is 420. Now from the center of the lens system, we have to subtract 4, we get minus 460. So this is the answer. So we are getting two different answers when the objects are coming from both the sides. For the first case, we are getting at minus 216. The second case, we are getting minus 416, which means the part of the question, does the answer depend upon which side of the combination the parallel beam is incident? Yes, the answer depends upon the direction of the incident light. So is the notion of effective focal length is useful? No, not useful, because it is getting different values. Final image depends upon the direction of incident light. So the notion of effective focal length is not useful here. Now we have another part, second part, B part of the question. The same setup as in figure A. Both the lenses are separated by 8 centimeter. An object of height 1.5 centimeter is placed 40 centimeter from the convex lens. Find the magnification. So we will try Using this equation, we will find the image formed by the u value and v value we have found. So this is v1. Now for u2, it will be 120 minus the gap, which is 112 centimeter. f2 we know. Now find v2. v2 is minus 560 by 23. Now to find the magnification, it is m1 into m2. Magnification by both. m1 is v1 by u1, m2 is v2 by u2. All these values we know. Substitute them, simplify, we get magnification as 0.65. So magnification formula is this. So height of the image is m into height of the object. We get 0.975 meter. So we get a diminished image. Thank you.